Okay, so now for the documentation. So here we have the instructions as to how to start a new game, what all of the main processes do, how the user will initialize each of these things. And then we go into the class list and we see the hierarchies for many different kinds of things. So if we look at something new like the OBB, we see the class hierarchy shown right here. The different functions are listed with the appropriate data and everything. If we go into something like the visualizer, we see many different commands linked to different things. Instructions for what the each of the things do, and they instruct the user as to proper times to use them and everything. Like the object must be registered for collision, obviously showing a point and saying what the effect is going to be. If we go into something like the Rojo math function, here we can see what the intersection types are. If the user would need to reference any of this stuff, the different target direction. Let's look at this. It says the kinds of things that need to get passed in, what everything does, and then they link to different related classes into each of these things as well. All right, now to go over my personal project, the UI system. So in this system, I have a mouse event manager and a mouseable class. It catches both clicks, left clicks to be specific, left click release, and hover end. And the user can register for these with the mouse registration command, and it goes into mouse hover event manager, single click event manager, and these types help distinguish between each of the things as well. So if we go inside the hover event manager, for example, here hover event collection just stores a list of mouseables. When we go in here, we have the registration with the reference so that we can have constant time erasure. And we go through, we make sure that the region was hovered for a mouseable. We go in here and we just test the mouse position. So here we have a register with the reference, and then we use it for constant time erasure. We go through, we make sure that we hovered the region, and we test the mouse position. And then we only do it on the closest one. So if we go back over here into our diagram, we have our UI element itself. UI mode scene, this is for the UI mode versus the regular mode. And each of our different behaviors for the UI elements that the user can set. Our UI wrapper class over here, which handles the callbacks, and our UI manager. So there is a big list of things that gets done with this UI system, but I thought it'd be best to have a report to kind of like group everything into one. So first things first, what was left out? Nothing. I pretty much got everything done that I wanted it to do. I described exactly what those were later, but I got everything done that I needed this thing to do. So the features for the user can create UI widgets from a text file. And if we want to go ahead and look at some of these text files, I made several for in this side of the project. Here's a look at the HUD. So here I have our timer, size text, different health bars and everything. We want to look at the game over screen. We have our two buttons, the screen, some sprites. Look at the title screen where we have our two buttons, our title screen, and the score attack text, different things that get overlapped and not overlapped. And we can reposition things from within UI mode. So, and we can save them, and the user can enter this here in the load resources. So if we go over here into our UI mode, yeah, we'll look at the game over screen for an example. We head inside and we see that obviously none of the behaviors are happening or everything, but I can click and drag these things into different positions. The Z ordering is what determines what happens to them. I can even take this title screen away, and they all get rendered into their correct spots. And I'm not going to save this, obviously, but if we can switch this around to even to like the tester one, whatever needs to get done can get set up in here. And yeah, this is the original with the sliders and everything like that. And then in the UI element, it can be used as a reference from within these functions. The reference can get retrieved from the UI manager. Although in my system is typically done through the level data. But if we want to look at the title screen, for example, here we get all of our, well, let's just first load UI. Let's look inside here. This is where we can instantly get to get into game UI based on the title, whether or not we set it active. And this uses the key system to make sure that it's actually there, and we let the user know that they're not, so they're not pulling out any random things that don't exist. And this gets it from the active UI. And just to go on the slightest tangent, but not really a tangent because it's an important system, to load these UIs, the UI manager goes in and loads each of them line by line. And we have a file reading system with a bunch of asserts and line numbers to ensure that the user knows that if something goes wrong, they know exactly where it happened and how it happened. And I have a couple of max lines to be read in, and this is some of them. This one's 0 because the UI sprite has only default values, so everything that gets written immediately. Any extra parameters is what is defined right here. So, for example, if we want to look at the UI slider over here. The slider can have many more parameters that can't be handled by default, such as direction and max ratio, which aren't default. So I have to specify that right here to make sure that the user is putting in all of the required custom values for something like that. I separated the reading in of each of the different UI types into their own functions, given that they need their own things to get handled. I keep a running track of the line that we're on and the list of the lines of UI from reading them in the file. So if we look over here, load UI from lines, for example, is where we create a UI. We add it to the list, and then we go through we iterate through each of the lines right here, going one by one, and we make sure that we're turning them into the correct objects right here. And given that we're keeping a running track of the line that we're on and the UI, we can go in and iteratively create each of our UI elements. And right here at the beginning of the game, when we're not in UI mode, we'll load all of the UI. Is the top level right here, or we can. This is used by UI mode to load just the one, having our saving, getting things, setting things to active, and we make sure to reset all of our UI elements to be back to their original state. And as working on the user side, especially with the UIs, I realized that you want your UI elements to go back to the state that they were in, that you put them in to start. So it is very useful to have these reset, deactivates, activate elements by range. For example, in the title screen, we don't want our non-overlaid things to show up at the beginning, so we order them in such a way that we have our initial ones activated by range, and then our secondary things not activated at the beginning. And now to go back here, UI elements can be used as references. So I have a static cast that I can do, and that is over here. I use a template function with the derived UI element. So if we look at things that call this, we saw it in the title screen actually. This is so that the user can get their UI elements just knowing what index they are inside of this file right here, and it does runtime type checking. So if I do title screen, it is not going to let that happen because that's just not a valid. That's not a derived type from a UI element. So we make sure to check those things. We get each of these. And I do have some commented things here, but that's because I was playing around with an idea for having collections of objects inside of UI wrappers, but it didn't really pan out. But we still have a nice little structure going on here regardless. So if we go inside of our play button over here, which is a UI wrapper, it catches these callbacks right here. Depending on the UI element will send itself within the callback as well, so that things can know which UI element was done. I didn't really use this functionality too much, but it is there, and I think it's essential for something that can parent multiple things. And I set this play button as the parent of this button. And if we go inside and look at something like button behavior, over here in button behavior, we iterate through each of the owners, and we do the UI callback on them. And obviously this would only get called if the mouse event manager notified of this kind of thing happening. So process hover event in here, mouse hovered, and it goes into each of these. So if we go in and look, we see the behavior state, we go in button behavior, and it goes through. And so yeah, the behavior is set by the user programmatically right here. They set it within, and they can get it from the behavior collection. And I know I had something that said it was the Rojo UI was the common thing, but there's actually something else. UI system, and the user can do this for a common elements of every kind of UI element that is present. The UI wrappers, I covered this, and they must override the behaviors, and this is so that the user isn't the user isn't overriding any button functionality. No, the user isn't parenting any UI elements that it isn't catching the button functionality for, because it has to define them. The UI elements can't know what to do with their behavior otherwise, and it makes it so that the user doesn't know what they're missing when they are parenting a UI element with one of the wrappers. It just makes sure that they know exactly what it is that needs to be defined. And yeah, they can attach it. They store it in a vector, and yeah. So the reason, that I wanted to discuss this, the reason I chose vectors for this purpose was, if I go over here in UI element, the reason why I chose vectors for this purpose was because vectors. I use the UI elements in many different locations throughout the code, sometimes the same UI element in different locations, and that makes it so that it's hard to define exactly how many parents a UI element is going to have. So it's best to store it as a vector that is can change in size efficiently, and I need to iterate through them for the callbacks, which vectors are good at as well. And here's some of the code for these. I can set so I elected to use a lot of virtual functions that the user can override to allow for different behavior, especially if they were to want to create their own UI elements. I have a lot of virtual functions that they can override the behavior on. And something that this is an example of on, so if we go over here into UI Sprite wants to wants to override the activate and deactivate so that it can handle its current render target between its overlay and its non-overlay. This could be obviously be expanded into the other UI elements, like the UI slider could also have this behavior inside of it, but currently it just doesn't offer that. The UI sprite is the thing that handles that. The structure of this is so that you can have layered UI elements, and they need to be separate. So I designed it this way so that the slider can do slider behavior, and that if you wanted an overlay on it, you would attach a sprite like behind it or something that would highlight the whole entire thing. So you can, and that's the reason for the UI wrapper and the multiple ownership kind of thing, is that the UI elements can be paired together in different ways to allow for these kinds of like different effects. And so here's my game over, where I just have each of these different buttons, and it allows for the grouping of objects and to make UI creation efficient. Mash registering in the scene, can access them in the main HUD level data. So I have a event listener. This is, so the document is not entirely up to date with the changes I've made today. But here I have an event listener, and just to show what this is, it's just, it catches notify event from when it registers. And so this does UI updates. This catches them for at least the time attack one. We register for listening to different events, such as tank damage, and anything that's just sending a general HUD update. And I can go through and select to which correct UI element to activate, depending on what the current state of the things I'm looking for are. And I have a active in scene check in here to make sure that we know whether or not our UI elements are registered or not, and that's just to provide to the user so that they can have a way to verify that, because especially with UI elements, it's very easy for things to try and activate things that have already been activated. So it's good to have those kinds of checks in place. And here we have a sprite string that we get from our UI string. We adjust its position programmatically. And now for the main intended uses. So the idea of it was just bare bones, the quick creation, placement, and display pipeline for UI elements, which I think it does it very well. I have made in the past 2 weeks or even week, I've made many of these UIs, and they just handle things very efficiently. Here's how I do the victory text, where I just put them all into the same spot. And for the HUDs, I can set things up how I need them, and it just is so much more helpful to have something where you can just click and drag and place it in the position that you kind of want it to be, so that you don't have to sit there and waste a bunch of time positioning them correctly. And at the very least, for example, the time text, I can have it in the correct X position, and the Y position will constrain. I'll be able to constrain that accurately after the fact. And obviously, I could have added constraints to the UI system naturally, or in Engine, but it just didn't meet within the deadlines of everything. Not that I had intended for it to be there, but I didn't have time. And the separation of responsibilities between UI elements and UI wrappers, so that I can have, as I was discussing before, different UI elements and different behaviors split between several wrappers that are looking for, that are trying to listen for certain callbacks.